Okay, so in the last video, we just talked about how to solve stoichiometry problems, how you want to go, if you're given a word problem that is a conversion problem, you notice you've got a balanced chemical equation. When you want to convert from the quantity of one given reagent to a quantity of an unknown reagent or another reagent, you always have to go through that mole-to-mole ratio. But we said that's just one of the conversion factors you can use. You can be given the quantity of the reagent in any units, like grams or number of molecules, or moles of that compound, and you can be asked to convert to any units of the unknown. So the other reagent, like grams of the unknown, numbers of molecules, numbers of atoms of the unknown, and moles of the unknown. So the general tip is that when you solve a stoichiometry problem, you always first convert what you're given into the mole, if it's not already in the mole, and then you convert from the given quantity to the quantity you need using a mole-to-mole, so into the mole, then mole-to-mole, and then that quantity of the reagent you've calculated, convert it out of the mole if you need to. Sometimes you'll be asked to calculate it in the mole. So let's practice some more difficult problems now. This first problem says, what mass of aluminum nitrate, and then I've got the molar mass given, this amount here, 213 grams per mole, that's the molar mass of aluminum nitrate. So what mass of aluminum nitrate is needed to react with 0.093 moles of sodium carbonate? And then we're given the balanced chemical reaction. So what are we given in this problem? Yes, we're given the molar mass of aluminum nitrate, but the molar mass is a conversion factor. So that's not our given unit. That's a quantity we're going to use to solve the problem. What we're actually given is 0.093 moles of sodium carbonate. So we're given 0.093 moles of sodium carbonate. What are we asked to find? It says, what mass of aluminum nitrate? That's what we have to find, or that's what we have to calculate. So the mass of aluminum nitrate is the grams of aluminum nitrate. So here is our unknown, actually. It's how many grams of aluminum nitrate do we need to react with this many moles of sodium carbonate. Alright, so we're given the amounts of aluminum nitrate, sodium carbonate. We're asked to calculate the amounts of aluminum nitrate. Quantity of one reagent given, quantity of another reagent asked to solve. This is a stoichiometry problem. So what do we always have to go through? The mole ratio of the balanced chemical equation, which is 3 sodium carbonates for every 2 aluminum nitrates. But let's start at the beginning, a very good place to start. We're going to start with what we're given. We're given 0.093 moles of sodium carbonate, Na2CO3. We want to convert moles of sodium carbonate into moles of the quantity we need. Notice we're already in the mole, so we're going to skip the in the mole. We're just going to do a mole-to-mole. That's what we're going to start with. And then perhaps we'll do an out of the mole. We'll talk about it. So I always do my IMOs. Into the mole, mole-to-mole, out of the mole. We don't need to go into the mole because the reagent's already given in the mole. So now we're going to do our mole-to-mole. So we're given moles of sodium carbonate on top, so we're going to put moles of sodium carbonate on bottom. And we're asked to calculate aluminum nitrate, so we're going to put our aluminum nitrate moles on top. And yeah, I never actually write inside my parentheses. I'm bad like that. Alright, so I've got a moles of sodium carbonate on top, or in the numerator, and I've got one on the denominator, so I'm converting to moles of aluminum nitrate. Let's put in the numbers. It says for every 3 sodium carbonates, and that's on bottom, I need 2 aluminum nitrates. So I'm going to put my 2 on top there. Alright, so we didn't need to go into the mole, but we did a mole-to-mole to talk about aluminum nitrate, to convert to aluminum nitrate. And now we're actually asked to calculate grams of aluminum nitrate. So we need to go out of the mole. We need to go from moles of aluminum nitrate to grams of aluminum nitrate. Alright, And this is the molar mass. Grams per mole is molar mass. So for every 1 mole of aluminum nitrate, remember up here it was given, we have 213 grams. Alright, so now I've got the mole of aluminum nitrate knocked out. I'm converting to grams of aluminum nitrate. Just a matter of picking up our calculators. So let's write it in. We've got 0.093 times 2 times 213 equals, divided by our denominator, so divided by 3. I got 13.206. 13.206. Notice we're given 2 significant figures when we start. So we're going to round to 2 significant figures when we end. So that'll be 13. But 13 what? 13 grams of the aluminum nitrate. 13 grams of the aluminum nitrate. Alright? Alright, I made a mess, so I cleaned it up. And let's look at the next one. Practice is going to make perfect with these. The next one says, what mass of HCl, so once again we want to know grams, so how many grams of HCl, and then we're given the molar mass of HCl here, is produced when 1.81 times 10 to the 24th molecules of hydrogen, that's our given right there, 1.81 times 10 to the 24th molecules of hydrogen react completely in the following chemical equation. Alright, so once again, we're given the quantity of one reagent and we're asked to calculate the quantity of another. That's stoichiometry. We have to use the mole relationship to solve the problem. We've got to go through the mole. So remember, IMO, we're always going to go into the mole, and then we're going to do a mole to mole, and then we're going to go out of the mole if we need to. Alright, so here we are given, what's our given quantity? 1.81 times 10 to the 24th molecules. So are we in the mole and are given? No. So we've got to convert molecules into the mole first. So we've got 1.81 times 10 to the 24th molecules of what? H2. How do I convert molecules into the mole? Into the mole, you're going to use Avogadro's number. Because if you're given the number of something, you're going to convert it to moles using Avogadro's number. So I'm going to convert molecules to moles of H2. So for every 1 mole of anything, how many is it? 6.022 times 10 to the 23rd of anything. Alright. So I've got a molecules on bottom and molecules on top. Those cancel. Okay, so I converted into the mole. So now I'm in moles of hydrogen. Now I need to do my mole to mole. I need to convert moles of hydrogen into moles of HCl. This is where I use my mole to mole conversion. So I've got a moles of hydrogen on top, so I'm going to put my moles of hydrogen on bottom, so they will cancel out. And I'm going to put what I'm converting to always on top. So I'm converting to HCl. So there's my moles of HCl. Always out of the box. I never make them big enough. Alright, so let's see here. What's the mole ratio? Let me erase so we can see. Okay, so for every 1 mole of hydrogen that's on bottom, we make 2 moles of hydrochloric acid. Okay, so there's our mole ratio. That's my mole to mole ratio. So I went into the mole, I did a mole to mole. Now, do I need to convert moles of HCl to some other unit? Remember that I was asked to calculate the grams or the mass of HCl. So I need to convert moles of HCl to mass of HCl. I do that using molar mass, which is given in the problem. For every 1 mole of HCl, so I've got a mole of the HCl on bottom and top, so that's why I did that. What am I converting to? Mass, so that's going to be on top. We're given that HCl weighs 36.46 grams. Okay, so HCl, mass of HCl, we went out of the mole and we solved for mass. Now it's just a matter of calculating. So I'm going to grab my calculator and I'm going to put all these numbers in. Now remember, make sure you know how to use your calculator with all these Okay, let's start all over again. Okay, I forgot to press play or record. So I am going to go ahead and walk through this problem again. So let's set it up. I completely forgot to press record and I started working the problem. So don't look at the answer. We're going to do it again. Okay. So this problem says what mass of HCl, what mass of HCl, mass is grams. So we want to know how many grams of HCl we're going to make. Is produced when 1.81 times 10 to the 24th molecules of hydrogen. So here's our hydrogen. We're given 1.81 times 10 to the 24th molecules of the stuff. Reacts completely in the following equation. So how do I know that this is a stoichiometry problem again? Okay, I've written down what I've given, 1.81 times 10 to the 24th molecules of hydrogen, and I've written down what I need to find. I need to find the mass in grams of HCl. When you're given the quantity of one reagent and you're asked to calculate the quantity of a different reagent, you have a stoichiometry problem. And you must always use the mole-to-mole ratio to solve the problem. Okay? So let's go back and let's see what else we're given. Because there was another number given that I didn't put in here. It was in parentheses. See this number here? 36.46 grams per mole. It said, what mass of HCl, parentheses, 36.46 grams per mole, that is the molar mass. Grams per mole is always the molar mass. So that's the molar mass of our HCl. That's a conversion factor, not a given quantity. So we will not treat it as a given quantity or something we need to find. It's just a conversion factor. We could have calculated the molar mass of HCl if we wanted to, but it's just given there as a shortcut. Alright, so now we're going to solve this problem. It's stoichiometry said, going from one reagent to another. Remember the stoichiometry rules. We're going to do IMO. We're going to convert into the mole. Whatever we're given, if that quantity is not in the mole, we're going to convert it into the mole. So for what we're given molecules of hydrogen, and we need to convert that to moles of hydrogen. That's what's meant by going into the mole. We need to convert the quantity of molecules of hydrogen into moles of hydrogen. Once we do that, we're going to do a mole-to-mole. We're going to calculate the moles, from the moles of hydrogen, we're going to calculate the moles of HCl, what we want to find. And then we're going to go out of the mole. Once we calculate the moles of HCl, we're going to calculate into the unit we're asked to solve for, which is grams. So we're going to convert moles of HCl into grams of HCl. So we're going to do an IMO. And into the mole, a mole to the mole, and out of the mole. Alright, so let's just start by writing down what we're given. We're given 1.81 times 10 to the 24th molecules of hydrogen. And I've already written that down, so I am going to keep it there. We're going to convert that to moles. So we have molecules given, so we're going to convert numbers of molecules to moles of hydrogen. This is Avogadro's number. For every 1 mole of hydrogen, how many molecules are there? For 1 mole of anything, how many molecules are there? It's the same number, right? 6.022 times 10 to the 23rd. Okay, so we're going to convert molecules of hydrogen into moles of hydrogen using Avogadro's number. Alright, that was our into the mole. We've done that. Now we're going to do a mole to mole. We've got moles of hydrogen. I want to convert moles of what I'm given into moles of what I need. And I need moles of HCl, so that goes on top. We're going to use the stoichiometry, the coefficients of the balanced chemical equation, to fill in our numbers for our mole ratio. So here we have 1 mole of hydrogen, and here we have 2 moles of HCl. Okay. And then finally we need to convert out of the mole. So we converted from moles of hydrogen to moles of HCl. But now we need to convert moles of HCl to grams of HCl. And we're going to use the molar mass to do that. It's given to us, like I said. The molar mass of HCl is 36.46. So for every 1 mole of HCl, it weighs 36.46 grams. Okay, so now my final unit here is going to be the grams. So I've got grams of HCl. We just need to calculate how much that is. So let's see here. I've got 1.81 times 10 to the 24th. Hopefully you're doing this too. Make sure you know how your calculator works. So I've got the 1.81 times 10 to the 24th times 2 times 36.46 equals. Okay, so that's my whole numerator. I got like 1.3198 something times 10 to the 26th. I'm going to divide that by the denominator. Now, whenever you have a big, large number like this in the denominator, you're always going to put it in parentheses. So I hit divided by parentheses 6.022 times 10 to the 23rd. Close my parentheses. And I get a big number, but not huge. I get 219 grams of HCl. 219. Now I got a whole bunch of numbers behind that, but there were 3 significant figures in the exponential number given, the quantity given. So I'm going to need 3 significant figures in my answer. Alright, so there's another example for you of using stoichiometry to solve a problem. Given one quantity, calculate a different quantity using the mole ratio. And there's plenty more for you if you want to try some in the notes, if you want to try some in the text to try as many of these as possible, because we're going to move on in the next video to limiting reagents, which you'll have to do, basically you'll have to do a stoichiometry equation twice, calculations twice in order to figure out how much reagent you're making. But go ahead and practice as many as possible. How will you know when you conquered this? When you can go to the back of the chapter, you can try one of those blue problems where the answer is given at the end, and you don't need your book, you don't need your notes, you don't need anything. You can solve that problem by yourself, and when you check the back of the book, you get the answer right every time. That's how you know you've worked up to it. And the only way to do well at stoichiometry is just practice, practice, practice. All right? So keep practicing.